Yeah, thank you for having me. Let me see. So, hey, my name is Mads. I'm the target maintainer for a lot of things, but as Stefan said, for example, the Apple targets on the Rust compiler, and I'm the maintainer for Winit as well. So if you are having any problems with rendering on macOS and iOS, that's my fault. So this talk is going to be not so much about Winit. It's going to be about a crate that I've written, a set of crates called opc2. Stefan asked me to do a talk to like introduce it a bit, maybe make it easier for people to get started with. So my goal for today is to give you an introduction to some of the technology that underlies on iOS, and then maybe I want to inspire you to try to use these platform APIs in maybe weird ways, or maybe just in ways that improve your application. So that goes for iOS, but also for macOS as well. I'll try to show a few demos throughout the talk. So this is going to be about platform APIs. This is really important for, like, this is the underpinnings of everything that Bevy does. If you need to do anything on the platform, like if you need to do rendering or anything like that, you need to interact with the platform. So currently in Bevy, there's a few it uses a lot of cross-platform crates from the ecosystem. This is Winit that I maintain, WGPU, CPAL for audio, stuff like that. And these all use these provide cross-platform abstractions for whatever the platform provides. And the underlying crates for these is what we're going to talk about today, which is these opc2 crates that I maintain. It's similar to the Windows crate, if you've seen that one, or the Rustix, or maybe kind of like libc, but for iOS and macOS. I think it's useful for you to know about, because if you run into trouble with one of these crates that Bevy uses on iOS or macOS, then you're gonna need to go in and fix it using, like, you're not gonna need to know about the underlying technology a bit. So I think it would also be useful for you to know about, because there's a lot of things that Bevy doesn't really expose yet that the platform exposes. So I'm not going to read this entire list for you. You can read it yourself, but there's like a huge swath of things that could be interesting to use, either in a game, if you're developing a game with Bevy, or if you're doing more general GUI stuff. One example here is Stefan has been making some great crates for making, I think, the App Store purchase stuff easier from Bevy. Okay, so now that so that's like the scene. We want to know about the platform APIs. Well, this is the platform APIs. It's Objective-C a lot of the way. So a quick introduction to this. It's a superset of C that's object-oriented, and it is what everything on Apple platforms are written in. It's like the platform API, if you will. Currently, like Apple is doing, if you've heard of Swift, that's their new programming language, but a lot of the old stuff is still written in Objective-C. So if you want to do anything on Apple's platforms, then we need to interact with Objective-C. So I'll show an example of, like, my example here is going to be opening a URL in the web browser, and I'm going to use the UIKit framework for this on iOS. So for this, we'll need these APIs. It looks like this in this header file. You have this interface, and then UI application, which is a class, and then you have an initializer method, which gets the application, and then you can call a method on the application to open a URL. And you don't need to know too much about this. I mostly want to show you the way that we use this. So we use this by, or in Objective-C, the way you call a method is with these weird square brackets. This is a method call. So you have the class UI application, and then you call the shared application method. And then you get an app, and then you can use that to call something else. Then you call the open URL method with some options and with the completion handler. This colon here is like the separation between arguments. I know this looks weird. Hopefully you shouldn't need to care too much about this, just to give you an idea of what we're dealing with. So if we want to access this, this is how, like the canonical way, if you want to open a URL on iOS, this is how you do it. So if we want to translate that to Rust, it looks something like this. And so we take the UI application, call a static method on that, and then call a method later on the application. And I know it's like this API that I show here is something that the OBC2 project provides, and it's completely auto-generated from this declaration. So it has a bit of weird names. Like if you're gonna ever interact with this, you're gonna have to live with these weird names. That's how it's gonna be. It's ugly, but hopefully you can see that it's not too much like it's not too different from what you would have to write in Objective-C if you were so unfortunate that you had to write Objective-C. So a few things here. We're using this ampersand because we're creating new objects here. We only need to pass a reference. And we're using sum here because the completion handler is optional. And we use this RC block thing here because we need to convert a Rust closure to an Objective-C closure. Those are called blocks. It should be fairly obvious when you look at the signature. Like if you go onto docs.rs and look at the signature for this method, it should be fairly obvious how to call it, hopefully. Okay, so that was an introduction to Objective-C. You've seen a little bit of how it works. So I'll show you a demo of how we would do this. So I have here the iOS simulator open, and then I am gonna run a small application. Like it's gonna do what we saw on the slides. It's gonna open a URL, the example.com URL, when we press a button. Let's see. So, yay, it works. Okay, so that was the demo. Now I'll show you a few things that are useful to know about Objective-C, a few more things to make it easier for you to really get into how to do this properly. So in Objective-C, there's a thing that a lot of things must be accessed on the main thread. It's like it's not safe to access it from any thread. It must be single threaded. So we need to use the Bevy. In Bevy, we would use this non-send marker system parameter to tell the scheduler that we need to run this system on the main thread. We're doing this in the example. And this also, so then to actually get the UI application in this case, which must be accessed on the main thread, we would use this marker type. And this unwrapping here is checking that we're actually on the main thread. Another thing that's pretty common when you are interacting with these Objective-C APIs is something called delegates. So a delegate is basically an implementation of a trait that provides callbacks. It's like a big set of callbacks for your object. So one example here is the application will terminate callback, which will be called when your application terminates. And you would, to access this, you will need to create, it's a bit weird, you actually need to create an Objective-C object and then register that with the runtime and all sorts of stuff. We have a macro to make some of this easier, but currently it still needs quite a bit of unsafe. I'm working on that. But yeah, okay, so also it doesn't really work that well in Rust Analyzer yet, also working on that. But you can do it. You can make these Objective-C objects and you can give them to the to whatever you're working with and then receive these callbacks. Another thing to be aware about is memory management. So often you need to take something that you have gotten by reference, for example, the actual application we're working with here, you get that with a reference, then you need to store it for later use. So for this, we can retain it, and then it goes into this retained wrapper type. It's basically an arc, the Objective-C equivalent of an arc. So yeah, useful to know that this is something you can do. Another pattern that I want to show is completion handlers. We saw this a bit before with the opening the URL. You often have this this callback that happens at a later point. It's Objective-C's way of doing async, and it is a bit difficult to integrate with Rust, especially this tick static lifetime here. I'll show you later how we go about that with Bevy. And the last pattern to be aware of is notifications. So often it makes sense that, or often there's some system level thing, for example, the theme of the application, or the theme of the system, like whether it's in dark mode or in light mode, that's useful to know, or that like you want to receive, you want to know when the user changes this. And the way that it's usually done in Objective-C or in Apple's APIs is with notifications. And yeah, there's a lot of unnecessary stuff here, honestly. I might make a wrapper to make this easier, but yeah, be aware that this is something that you might need to use or look into if you need to know about some global update or change in the state of the system. Okay, so I talked about a lot more about Objective-C. I'll show another demo, which is a bit of a different kind of notification. So let's see if it's going to work. So just to show you what you can maybe do with having more access to the platform APIs. I made this weird little game where it's played entirely in the iOS notifications. So we have to allow them, and then here's our game board. So there's this little character, and we can try to go towards the items. Yeah. Look, I'm not a game developer, but I don't know. I thought it was something fun that you can see that may be useful for you if you're developing a game. You probably don't want to develop a game entirely in notifications, but you might want to show a notification for something for your game, right? And therefore, it's useful to know how to access these platform APIs. Okay, so something that's specific to Bevy is how to do these tick static callbacks. So this is something that Objective-C does a lot. It's like you basically have a function where you have some closure that is going to be called at a later time. And this is a bit hard to make nice in Bevy, I feel. The best way I found was to create a message where you pass the state of the completion, and then when you do something, for example, when you open the URL, you send the message to a channel, a normal Rust channel, and then on every update, you check this channel and see if there's any new messages, and then you write it to a message writer, and then you can, inside of your normal Bevy code, inside your systems, you can like call a function where you open the URL, and then you can handle this opening with a message reader. Then you can then you know when the event has been sent, whether it was successful. I'm curious, like you're probably gonna all be telling me about better ways to map this using maybe component state or something. I don't know. I would like to know. This is the best way I found so far to make this pattern work. Okay, as the last thing, I'll show an actually useful demo. iOS has a lot of accessibility features, but one of them is to allow you to adjust the content size. Like users can do that in their system settings. They can adjust the content size if they have poor eyesight or something like that. So here we have a text2D component, and I've hooked it up such that when the user's preferred content size changes, the text size will change as well. So if we go into system settings, into accessibility, and we say that, okay, I want some larger text, you can already see we are getting notifications about it. These are the notifications that I talked about before with the NS Notification Center. And if we go back to our app, we'll see that the text has been made larger as the user requested. This is probably too large. You would have to tweak that. Ideally, I think something like this should probably be in Bevy itself. Hopefully it should do this automatically, but currently it doesn't. And that's why you'll need to drop into these lower level platform APIs. That's hopefully what you've gotten a little bit of an idea of how you can do with this talk. Yeah, so I think that's it. I would like to encourage you to go and write wrappers around these OBC2 primitives to make this easy to do. Also on all sorts of, like on Android, there's probably something similar. So it would be nice to have an API for accessing notifications on Android and iOS, for example. Yeah, if you are interested in more, you can go to these links, or you can contact me on the Bevy Discord. I hang out on the Mac and the iOS channels. Or if you want to complain about Winit, you can do that as well. So yeah, I think that's it.
Awesome, Mats. Thank you so much.
Yeah.
it's still like black magic to me how you made it to work like this. But it's just great to have. That's for sure. Okay, let's dive into some of the questions. You mentioned Swift. Where does that leave newer Swift platform APIs?
Okay, so yeah, newer, we can't support that because the thing is with Swift, they have a completely different API. Like the entire thing is different. So with Swift, we have to do something a bit different. Currently, we have to basically, I actually have some extra slides for this. So something like this where you make a C function that calls whatever you want. So this would be implemented in Swift, where you make a Swift function, expose it to C, then you build it in a build.rs, and then you call it in Rust with like an unsafe extern C, something like this. This is a common pattern, and I think there are also other crates for helping you do this with Swift. But it's not something we can, or that I expose in these OPC2 crates.
Yeah. But as a follow-up, I mean, Swift has a stable ABI, right? So someone could go and say, okay, I'm going to be Mats 2.0 and write the Swift Rust in like bridge.
Yeah, you could, and it's just so much more work. Like the API for Objective-C is like, it's already hard. There's already pages upon pages of documentation and stuff to get the memory management right and all sorts of stuff. To do it for Swift as well is like a huge endeavor as well. But I would like to see it. Like if somebody is going to do it, I'm going to follow that closely.
Yeah, you got enough crates under your belt already, right?
Yeah.
Makes sense. Okay. Yeah, I think you mentioned that already yourself. It's a lot of unsafe. Is there any way to make it more safe? You mentioned some ideas. Can you maybe elaborate?
Okay, so for example, let's see. I mean, most of this is internal, right? It's something that I'm working on slowly to make things better. One of the things that is difficult, for example, here, the arrow type here, for example, currently has to be a pointer because of complex stuff. It's like Rust doesn't have a good way to allow us. It gets into higher kind of generics where we have to say that we want the ampersand type and like the lifetime we want it to be. I don't know. I can't explain all this stuff. It's
hard.
It's really hard. So currently you have to do small unsafe stuff like this where you have to manually convert this pointer to a reference to be able to access it nicely. I have some ideas for making it better, but it's really, we're kind of running against the limit of what Rust currently allows me to express in the type system.
I mean, that's Bevy's specialty, right?
True, yeah.
All right. Okay. It seems straightforward to go from Objective-C to Objective-C2. But what if I do not even know Objective-C? Like, what's the way to even start?
So one thing I would recommend is like describe whatever you want to Claude, have it generate some Objective-C, and then either make it convert it to OPC2. Sometimes it can do that, sometimes it can't, or you do it manually. Yeah, that's my best advice here.
Vibe coded, I got it.
Honestly, yeah.
Yeah, I mean, there's a lot of Objective-C code out there to have good experience of, right?
Yeah.
All right, makes sense. Okay, last question. Bevy request uses a pattern allowing observers to react to native events. Oh, I guess that's regarding your message
my
writer
question,
implementation?
I think the problem with observers is that it happens, I guess it happens immediately, so you don't have access to other systems, right? So you can't like change, if you wanted to, when the URL opened, you wanted to change some button to something else. That would be kind of hard, is my understanding. But maybe I'm wrong about that. Maybe it isn't.
I think observers are basically just regular systems. You can inject any dependencies from the Bevy world and do whatever with it. So that should be fine, yeah.
Okay. Well, maybe that's the better way to do this. I'm not too experienced with Bevy. Yeah.
No, I think that's fine. I mean, I've used the message reader and writer approach as well in a few crates. I think it's fair. So it's also always a trade-off between amounts of buffered messages that you expect to be sending, right?
Yeah. I actually looked at your crates for how to do this. So.
Yeah. Nice. There's actually one question in the chat. Has anyone tried Bevy on ARM? Which I guess is a clear yes, with the current Apple Silicon stuff being based on ARM, right?
Yeah, definitely.
But did that even have any effect on the crates that you maintain? The new target.
So at the time when I was creating it, the target existed already. So it's like there's a few platform-specific components, like we have to, for example, to make memory management faster. There are some things that are ARC64 specific, where we do platform or like target specific code, do some custom assembly there. But for the most part, it's the same thing across the board.
Yeah, makes sense. Well, all right. That's about it in terms of questions.
Yeah.
So Mats, I hope you get a big hand in the chat as well. Thanks certainly from my side for all the foundational crates that you're literally the impersonification of the XKCD image.
Yeah.
So please don't disappear.
Yeah.
And thank you so much for this. And I will do my best coming back to the Apple platforms again and try to put some more APIs into Bevy crates.
Yeah,
it was definitely fun using Objective-C too.
Mm-hmm.
All right, Mats, thank you so much.
And see you at Rust Week if anyone's going to be there.
Oh, good point. That's definitely a shout out that you're going to be around there.
Mm-hmm.
And open for more Winit complaints.
Yeah.
Awesome. Okay, Mats. Talk to you later.